And we are back live at Mandalay Bay for MIX11. I am incredibly excited. Dan Fernandez for our guest. Why don't you guys quickly introduce yourself? Ivan, if you want to go first.
So my name is Ivan Tashev, and I'm principal architect in Microsoft Research. During the development of Kinect device, I served as audio architect and created most of the audio processing algorithms there.
Awesome. And Curtis, if you want to.
I'm Curtis Wong. I'm a principal researcher with Microsoft Research in Redmond. And I'm the co-creator of the Worldwide Telescope with Jonathan Fay that you might have seen the demo today.
Awesome. Okay, folks, this is a live interactive. We are talking natural user interface. So send your questions to #CH9 Live on Twitter. We will get them answered live on stage. We will put you guys on the spot to answer all questions. Yes. Yes, this is...
it's getting hot.
Yes, exactly. So let's just kind of start off. Natural user interface. Now you work a lot with audio. So what is kind of like a good example of when you see natural user interface used well for audio programming? Because it really isn't ideal for all scenarios. So what are the scenarios where it's the killer scenario for interacting with technology?
So in general, when you say audio, this in general means an audio pipeline which provides enough good quality for the speech recognizer.
Okay.
So speech is a good component, but one of the components of the so-called multimodal user interfaces. In the modern computers, Xbox plus Kinect, or your media player, or your phone, we have multiple modalities. We have touch, we have gestures, we have color screen. And one of the components we can use is actually speech. Speech is very strong in browsing and searching from large lists. You can easily say, play me that song about submarines by the Beatles, and the system can go and browse over 30,000 songs and find the 3, 4, 5 most suitable candidates. But then it comes the moment when we have to select from a short list, and speech is already not as strong because we have to listen to the computer to read all
It has to go sequentially as opposed to your eyes can scan a list.
Can scan in parallel, and then you, with a quick gesture or touch, you can select the song you want. So pretty much speech is an important component of the multimodal user interfaces, but not the only component of multimodal user interfaces.
So, and when you say multimodal, it's making sure that you have two. Here's when it's good for. Here's once you have your list of 4. It's going to be a lot easier for a user to scan that list.
Exactly. If you use each of the modalities, buttons, GUI, touch, gesture, where it is stronger, this can combine it together, provide a very much intuitive user interface when you just look and use the machine. And the transition from multimodal to a natural user interface is when it is so much intuitive that you don't need training to use it.
Right.
This is what, in general, in most of the cases, we call a natural user interface.
Okay. And what about Curtis? What's your take on natural user interface? Like, where have you seen it? Where is it the best examples, and where is it kind of fall down, for lack of a better word?
Well, there are lots of natural user interfaces. I mean, the Surface has been an excellent example initially. I mean, I think we were looking at using Worldwide Telescope and putting it together with the Kinect, just because as soon as we all saw the Kinect Project Natal at that time, this is what we wanted to do is we wanted to control the universe just with our gestures, especially on a really big screen. And so some of the work that Jonathan did on the early version of the SDK was specifically to just build in some simple browsing and zooming and that kind of thing, and that's what we're showing here at MIX today.
Right, right. Now, another classic example is you see mobile everywhere. And with phones and sort of natural user interface, and we're seeing kind of touch take off as probably one of the best ways. What do you all think about, say, whether it's speech or some other ways to interact with your phone? Are we going to be doing gestures? What's your personal opinion? Obviously, not talking about products or anything else. But where do you see what is the way? What feels natural for phone use? Is it touch? Is it something else? Is it a mix of those?
Well, Bill Buxton always likes to say some things are good for some scenarios and that are perfectly bad for others. And I think what we're doing is we're bringing together more and more sensors that help us get a better understanding of the context of whatever it is that we're trying to do. I mean, with a keyboard and mouse, the explicit intention of what you're trying to do is pretty simple. Okay? With speech, it's a little bit harder, but it's also a way to do it in a really abstracted way that's ideal for mobile devices or things with long lists that you don't want to scroll through. So the term naturalness is really sort of in the context of understanding what's right, not just for the scenario, but what's right for you, because we all have our different sort of preferences of how we like to do things.
Sure. One of the things, and we haven't had a chance to talk about it too much, just because all the Connect SDK announcements. But you've done a lot of the work around Connect. Can you talk about Connect Audio? Can you kind of give people, I guess, the background of the work that you've done, and what's possible in terms of the types of audio-based applications that you can build? Like, what could you do? Imagine the possibilities.
Oh, let me start with the end. The limits of the possibilities are the fantasy of the developers which use Kinect.
Good answer.
That's pretty much it. Otherwise, the audio for Kinect, we had to overcome 3 extremely serious problems.
Okay.
First is the sound from the loudspeakers. Kinect is positioned very close to the loudspeakers, and they play a very loud sounds. You know, those gamers, they tend to listen to a very loud sound.
Sure.
So we have somehow to remove this sound and to capture just the sound from the room, from the gamer. The second serious problem was the ambient noise in that room. Humans, first they have 2 microphones and they have 100 billion neurons between them. So they do an amazing job in filtering out the ambient noise and listening towards given direction. We had to teach the Kinect device to do something like this. And the third was enormous dynamic range of the sounds we have to capture and process, starting from the loud signal from the loudspeakers and ending from the soft voice of a kid 4 meters away from the device. So there is a very complicated audio pipeline which does all the processing, and we can say that Kinect is the first in 3 major breakthroughs in the audio area. The first is that this is the first surround sound echo cancellation system on the market.
So that's surround sound noise cancellation. So I have. So what does that mean for developers? Say, the person talking to it. You mentioned some of the stuff. It's just I'm hearing all the ambient sound is gone, regardless of whether it's surround sound.
This means that you can have a surround sound system with 5 loudspeakers, and all of them sending sound, and our system is able to remove the sound from those loudspeakers. Because this is called acoustic echo cancellation. This is one of the oldest signal processing algorithms, but always it has been developed for mono. Every single speaker phone has something like this to remove the sound of its own loudspeaker.
Okay.
But the stereo and surround sound echo cancellation has been a long-standing research problem. And Kinect is the first system which has it, the first industrial prototype which we shipped out of the door and can remove the sound from all 5 loudspeakers.
That's amazing.
It was so serious that at some point in 1991, the inventor of the acoustic echo cancellation himself wrote a paper describing why in the existing at that time architecture, this is not a possible task.
That's always good when the person who built it says it's impossible. That's awesome.
The second breakthrough for Kinect is that we can speak to our speech recognizer and be understood from a distance. Most of the speech recognition systems require a closed-talk microphone, headset with a microphone, which provide the best possible quality. Even now, today, you see the microphone is pretty much close to my mouth as possible.
Right.
If you place this microphone 4 meters away, then what is going to happen is you will capture a lot of noise, a lot of reverberation in the speech recognizer. Even a human being will not be able to recognize it. And the third serious breakthrough in the Kinect audio is that for the first time we have so-called open microphone speech recognition system. In most of the cases, there is a so-called push-to-talk button. If you go in FortSync today, and in a Ford machine equipped with FortSync, on the steering wheel we have a push-to-talk button, which you press it, and this means for the computer, I'm talking to you.
Right.
In Kinect, we don't have this. We have a user code word, which has to be recognized extremely reliably, and this is provided by the high quality of the audio system which Kinect has.
So does Kinect do anything, or is this something that people can build upon? Because it seems like it's very sort of foundational APIs where you could build something to, say, recognize one voice versus the other. Say, I don't want my child to do certain things, so if they they try and hit commands to watch a movie or something that they can't do. Can I start doing things like actually get the signal processing and say tune it to recognize different voices? Is that something that's a feasible scenario?
So first, the straightforward use of the Connect audio pipeline is connected to the speech recognizer, and you can have a speech as a component of the multimodal interface.
And for people that have never programmed speech, this is, say, building a grammar, like you're building a set of a grammar being a set of commands, like turn on, turn off, whatever those commands are that you're setting for them, and it listens to that, and then based on that command, does a specific action. Is that?
So this is what we have today. It's called command and control, and it's a kind of a very rigid architecture. You just enumerate the set of commands, and this is the only thing you can say.
Okay.
When you say Xbox, you see on the screen there is a black background, white letters, and this is what you have as available set of commands. The audio pipeline, the speech recognizer in Connect can go way beyond that.
Okay.
You can have a relatively free phrase speech input, and this is guaranteed with a small change in the audio pipeline and the way we use the speech recognizer. So we can switch and transition from so-called context-free grammars to a so-called statistical language model, and then to have a spoken language understanding unit after the speech recognizer, which is pretty much a search engine which matches the fuzzy and not quite the disambiguated query from the user to a set of items, songs, movies, whatever we want to do search for.
Okay.
So this goes way, way beyond just this limited set of commands we have today. And to return to your question, beyond that, once you have the high quality audio, you can do a lot of interesting stuff.
Okay.
There I can say them and enumerate them as a research project. They may or may not find their way towards the actual product, but yes, we can do speaker identification by voice.
Ooh.
We can do speaker separation when you have a two-person speaking in simultaneously, and you can split this on two and have two instances of the speech recognizer. So pretty much that's a very cool scenario. You sit in front of your TV with your wife, she watches on the large screen the soap, and you watch the football game on the small picture-in-picture. But I can do voice control on my own small segment of the screen, and she can do voice control on the large screen, and we can do this in parallel. This can save families. No more arguments for the remote control.
We are saving families here, ladies and gentlemen. You've heard it here first.
You know what I think is amazing is that you look at each one of these components, the 5.1 and then the beamforming, each one of these is an extremely difficult problem. And when you compound all of these and they all work, it's really kind of a modern miracle that all of these things are so good as they are.
You know, a lot of people don't know the actual hardware that's in a Connect. Can you talk about because I've heard microphone array. As somebody that doesn't do a lot of speech programming, that I'm not even sure what that means. So what's kind of on the Connect, since everybody has one? So that it sounds like they have like an amazing microphone. Everybody's taking back an amazing microphone. But what's in the box?
So inside the device we have 4 microphones.
Okay.
So what we can do with 4 microphones is that we can sense when the sound comes from. Because the sound wave coming from this direction will reach the microphones in one order, and coming from another direction will reach them in a different order.
Okay.
So then we can combine those microphones together into a single output, which is equivalent of a highly directional microphone. So it's called beam. So pretty much we can point the listening point to given direction where we believe the sound source is.
Now, can you combine that with, say, since we know the location of a person, can we, if it's a directional microphone, point it where we think that person is?
And you can move the listening direction and to follow the person when it moves. You know, when they shoot movies, there is a sound engineer which holds this long directional microphone and points it towards the speaker who speaks currently. This is exactly what Connect does completely automatically.
Interesting, and that's all underneath the covers.
Yes. And once we have the high quality sound, then it goes towards voice chat, that goes towards the speech recognizer, and pretty much everywhere we need a clean sound. Speaker identification eventually in the future.
So I always joke that, hey, since now everybody has a Connect, they can just plug it into their PC and have the best screensaver detector when somebody goes into your office and say you'll be able to, you'll be able to take the screenshot of the person, stealing your laptop
Right.
and detecting sound. But how low of a sound can you actually hear? Like, you mentioned the small child 4 meters away talking. How accurate is it, and how good a microphone is it just to pick up such small sounds?
Okay, we can detect a small child from 4 meters away whispering, but I want to underline something here. Okay, we have that audio pipeline. This is good. What can bring a lot of more interesting things on the scene is actually combining all of those sensors. You mentioned speaker identification and the identification by voice, but you stand in front of that three-dimensional camera. We can get the coordinates of the major joints. So we have your kind of a bone image.
Sure.
Add to this
skeletal tracking.
The skeletal tracking. Add to this the face recognition from the camera. Combine those three together, and you can have a very, very good person identification and tracking.
Right.
From the moment you stand in front of the Kinect device, and again, this is in the future, this is just the potential opportunities the device opens. But
this is to unlock the ideas of people thinking about the kind of stuff they can build.
So pretty much in your Xbox, you can have registered users, and from the moment you show up, stand in front of the device, open your mouth, and we know who you are, what are your preferences, potentially which music you may want to order, so we have a substantial prior probability of your preferences. If you're a 27 years old male and you're the sole owner of the Xbox console, once you say, I want to play movie blah, probabilities that this is some kind of action movie is relatively high.
Okay.
On the other hand, if suddenly in the field of view of the camera we see an unknown, unregistered female skeleton, and you guess they confirm this with the voice, most probably we have to boost the probabilities of the romantic movies because the situation is completely different.
You tie this in with Bing ads, and I think we got a product.
Automatic movie play.
That's awesome. Actually, is it possible to do things like, I don't know if you've seen anything in research actually, check gender? Male voice. Have you all seen anything in terms of research for that?
This is
for sound
completely
processing?
doable. We can go even further. Again, I'm speaking as a research person, okay? This is not a promise or commitment for any future
Of course.
futures of our product, but gender recognition, emotion recognition, in general, making the natural user interface situation aware is something I believe we should go forward.
I love emotion recognition. That's like when you're screaming at somebody, no, it's your turn to take out the trash. It's, the Kinect starts playing soothing music or something, the spa channel on XM. So we are taking a lot of questions. This has been a great conversation so far. But just a reminder, pound CH9 Live, and we'll go through some of these. Now, I know some of the SDK questions we can't really answer, so just based on what's available on the best place to go is the Kinect SDK research site for what we can talk about right now. But I'll just go ahead and ask Al's question. You all can tell me where you can go with it. In the Kinect SDK, can you plug in your own audio into the speech recognizer, like from a sound or Skype call, for example?
So what is going to happen is that you plug it, connect to your Windows machine, and it shows up as a 4-channel microphone array. Windows supported 4-channel microphone array. On top of this, there will be a processing module which will convert those 4 noisy channels into one clean channel, and there will be a sample code which will allow you to plug the output to the speech recognizer. We strongly believe that potential users of KDK will have the ability to make voice-enabled spoken dialogue systems.
Okay, great. And I know Skype does have APIs for low level, so if you can get access to that sound, which you can write data and read data from Skype.
In general, yes.
Discorax asks, is NUI sensor device dependent, or do you develop the interface regardless of the device? So this is really, are we building the natural user interface based on the sensor device that we have?
I think that you should talk to that one.
So, natural user interface, as we discussed it, is the way we interact with the computers. And building such interfaces, every developer and designer uses whatever means and modalities we have available. If this is a mobile phone, then you can have speech, you can have touch. If this is your Kinect connected to Xbox, you have gestures. It is device dependent, but you use all devices, you have all means. Correct me if I'm wrong,
Exactly,
Francis.
yeah.
Yeah.
I mean, the whole thing about NUI is that the more sensors, the better. Hopefully, it's all about forming the larger context because, you know, reliable speech gives you one thing, but then, you know, some of the depth sensor and, you know, skeletal stuff will tell you something different. And how you bring those together provides the better picture of understanding of who your audience is and what you're trying to tell.
And how do you guys feel about, you know, when we talk about device, so far the world's still kind of in islands.
Yep.
In other words, I have my Xbox 360, I have my Windows Phone, I have, you know, maybe some other device, my laptop, and they don't necessarily talk to each other, or the ways they talk to each other is very rigid, and the ways I use them, you know, whether it's touch on one, connect on another, isn't really connected. How do you all see that in sort of a NUI where you have both your phone and your Kinect at the same time? Or, you know, you scan something in front of your PC camera and it knows to download information. How do you see these things working together?
I think part of what we're going to have to start moving towards is getting a generalized understanding of context where all these different sensors that we have in the phone and Kinect can all be part of a sort of a personally private context that can travel with you, whether you're on a particular device that the cloud will know about, or if you go into your car, it has a different context that it knows about there. So that is something I think that we need to start thinking about as part of our foundational platform for development.
Okay. I'm going to ask some more questions. What does the Kinect SDK API for audio look like? An event for spoken strings? And really it just mounts as a regular microphone, so you use the same speech SD API that you'd use for any microphone. Is that fair?
So when you plug in Kinect with KDK installed, you'll see a Windows supported microphone array. The same standard, we announced it before to ship Windows Vista in 2006. So pretty much the easiest thing to see how it is going to look like is to go to www.microsoft.com and to type microphone array in search, and you will see how the microphone arrays show in Windows. And in Windows SDK, actually, we have a sample how to use the microphone array processing block.
Oh, perfect.
So pretty much toward the 5 supported geometries, we add 6th, which is the Kinect geometry. That's it. You can reuse all the samples from Windows SDK. You can reuse all the samples from the speech SDK for the speech recognizer. We try to move to add new stuff as less as possible to make the job of developers easier.
So people that are already programming, say the audio array and using those Windows SDK samples, it's just a different microphone, for lack of a better word. Okay, very cool. Larry LA asked, can you suggest any sites or other resources for developers who want to follow where NUI is going? So what websites are you all visiting? And keep it clean, for God's sakes.
Well, we have most of the things that we're doing right now. We have an internal NUI site that we're using to share information between groups, which is particularly useful.
Okay.
Yeah. I mean, I think in the context of what they're asking, which is about NUI related to Kinect, I would say go to the research.microsoft.com/Kinect SDK, and there'll be more information about Kinect in relation to NUI there as we get closer to the
Yeah, I think it's more like where do you see, where's a good place for the latest things in NUI to come out? Or I don't know if you guys had a specific website or places that you go to sort of see the trends in the industry or that sort of thing. No? Okay.
I would pass on
So
that.
in general, there are several conferences dedicated to user interfaces.
Yeah.
But still, NUI per se as a terminology is kind of fuzzy. In general, pretty much everything which is user interface dedicated, we try to make it easy to use, natural. So think about NUI as a trend, as a direction we all follow, trying to use various sensors to make the interaction between the humans and the machines as easier for humans as possible.
Okay. Now, you both work in Microsoft Research. So how does, this is kind of like the classic how a bill becomes a law, if you all remember that thing. But basically, how do you take research in a specific field and then say within a product cycle, get it into the product team, and get it actually shipped. So like, what's the story? I know audio is a good example, and Worldwide Telescope coming out as well. How did they start from inception, maybe it was research paper, to a product that people can download or purchase in a store? How does that actually happen?
Well, I can just talk about Worldwide Telescope. I mean, Worldwide Telescope started about 9 years ago when Jim Gray was working with astronomers about the challenge of big data. And one of the challenges there is, how do we enable a federation? As the astronomy data was growing, where every year there was more astronomy data being collected in a year than all have existed in the past. And so the challenges that he was thinking of is to create something that he called the Worldwide Telescope, where different observatories would start to federate the availability of astronomical data so it would form sort of a virtual telescope. And what I was saying to him is that, we'll have all the federated data out there, but we still got to figure out where it is. I said, we need to create a rich visualization environment so that you can bring all of this together to get context for it. But in addition, I wanted to create an environment where people can tell stories about data in that space. That's what Worldwide Telescope is. It's a storytelling engine built on a really rich visualization environment that has connections to data underneath it. So if you imagine the future of big data, how do we solve some of the challenges around big data? I mean, one of it is to build visualization for it that has intuitive user interfaces, and that's what we try to do with Worldwide Telescope. The other is these idea of tours, that if you've seen a tour looks like a movie, but it's actually just a path in this data environment. So by having this path, it's a movie that's rendered in real time, but like in a video, anytime you stop, you're in that environment. And so if you have a story about data, you can create a path that brings in the data and shows somebody some anomaly that you're interested in, but then you can sort of pause and explore, bring in other data, annotate it, share it with somebody else. So that's sort of another way of starting to get your arms around the big challenge of big data, both sharing and annotating it, like we do with documents, because those are really small and easy to handle.
Right.
So that's sort of the beginnings of what we did with Worldwide Telescope, and a lot of what we're doing now. You can see a little bit in the Worldwide Telescope demo room. We have earthquake data, and I've showed this a little bit before. We're bringing thousands and thousands of rows in of like 2 years of earthquake data, and you really can't make sense of it in a spreadsheet. But when you see it in Worldwide Telescope, especially if you see it in time, you're seeing patterns that you've never seen before. We have these things plotted in 3D along with the magnitude of the data. So starting to explore things that way really seems like such a natural way to want to explore collaboratively. In NUI, we talked about room and wall size displays and room computers. Well, how are you going to interact with data with that, with that kind of challenge? Well, Connect is one way of having sensors to know who's there, who's saying what, to be able to have anybody control what's up on the display without having to, go to a keyboard or mouse. So the kind of foundational things that you're seeing in Connect are getting us towards that direction that Craig Mundy has been talking about.
And how about for audio and Connect? How'd you go from start to shipping product?
So in general, first, everybody in Microsoft Research does research in certain area.
Okay.
I was doing microphone arrays and audio processing and speech enhancements since the very first day I joined at Microsoft Research in 2001. And it just happened that when the time came and Xbox team started to think about Kinect and to add audio or not, pretty much I had all of the technologies in hand, and they were in a research stage. This means they can work on certain small, limited amount of data. They're enough novel to publish a paper on a scientific conference. The challenge actually of building the Kinect audio pipeline was to put all of those technologies end-to-end together.
Right.
And that was extremely challenging task. I had the opportunity to work with an exceptional engineering team, Xbox engineering team, and still the challenge was so enormous that at some point, the last 4 months before to connect to ship, I had to be basically drafted and had the office and desk there in the team to finish the audio pipeline and to make this thing to happen.
That's great. All right, so I think we are running out of time, or we'll take one more question. I'm being told we're out of time. So thank you both for coming on Channel 9 Live. And any websites you all want to promote, or just quickly?
Research.microsoft.com.
Absolutely.
Connect SDK.
Perfect. All right, thanks everyone.